Hey viewers, today I am going to give review of display of Samsung Galaxy S8 per second 8 Plus and the comparison of S8 and S8 Plus with S7 and S7 Edge. Before that I wanna list some point about what is new and what is improved from its old version of S series. That is S7 and S7 Edge. What's new? The Galaxy S8 has the following major new display performance features and display functions, which I cover in detail throughout the article. First, a new larger 5.8-inch full-screen display that fills almost the entire front face of the Galaxy S8 from edge to edge. Its display is 18% larger in screen area than the Galaxy S7, with almost exactly the same width but 17% taller. The home button and navigations buttons are now incorporated within the touchscreen display. Second, a new display form factor with a taller height-to-width aspect ratio of 18.59 equals 2.05, which is larger than the 16:9 equals 1.78 on the Galaxy S7, and widescreen TVs because the display now has the same overall shape as the entire phone. It is taller in portrait mode and wider in landscape mode. This provides extra space for notifications and for displaying multiple windows and content. Third, a new 4K high-resolution 2960x1440 Quad HD Plus display with 570 pixels per inch. Fourth, support for 4 screen modes and 3 standard color gamuts with high absolute color accuracy based on our extensive lab measurements. Fifth, a new full 100% DCI-P3 color gamut and digital cinema mode that is also used for 4K Ultra HD TVs, so the Galaxy S8 can display the latest high-end 4K video content. The DCI-P3 gamut is 26% larger than the Rec 709 gamut that is used in 2K Full HD TVs. Sixth, the Galaxy S8 is the first smartphone to be certified by the UD Alliance for Mobile HDR Premium, which allows it to play all of the same 4K high dynamic range content produced for 4K UD Premium TVs. Seventh, a new video enhancer that provides HDR-like expanded dynamic range for photos and videos that don't have HDR coding. Eighth, a new record high peak brightness with over 1000 nits, which improves screen visibility in very high ambient light, and provides the high screen brightness needed for HD. Ninth, a new user-adjustable white point with RGB color balance slider controls that can change the color of white for the adaptive display screen mode. 10th, new front and back dual ambient light sensors for significantly improved automatic brightness settings. 11th, a new night mode with a blue light filter that allows the user to adjust and reduce the amount of blue light from the display for better night viewing and improved sleep. What's improved? The Galaxy S8 also has the following improved display performance features and display functions, which we cover in detail throughout the article. 1. Higher screen brightness from 5% to 19%. 2. Larger native color gamut with 113% DCI-P3 for better displayed colors in high ambient light. 3. Improved absolute color accuracy. 4. Improved viewing angle performance. 5. Enhanced configurable edge display for the curved side screens. 6. Enhanced always-on display mode operated with IC hardware rather than app software. 7. Enhanced personalized auto brightness control. 8. Enhanced image processor for adaptive dynamic brightness and contrast range expansion. 9. Enhanced performance modes and power-saving modes. 10. Stronger curved Gorilla Glass 5 protecting the display. I will use 4 parameters to explain. Judge and compare the display of any device. For today it will be S8 per second 8 Plus versus S7 per second 7 Edge. The 4 parameters to explain: judge and compare the display of a smartphone. 1. Color gamuts. 2. Color accuracy. 3. Contrast and amp intensity scale. S4 display spectra. Samsung Galaxy S8 color gamuts. Figure 1 A color gamut in the dark 0 lux. Figure 1b color gamuts in 0 to 2000 lux. Figure 1 below shows the measured color gamuts for the 4 Galaxy S8 screen modes along with the new wide DCI-P3 standard color gamut marked by 3 black circles. The outermost white curve is the limits of human color vision, the horseshoe is the pure spectral colors and the diagonal is the line of purples. A given display can only reproduce the colors that lie inside of the triangle formed by its primary colors. Accurate white point. The circles in the center are the measured color of white for each of the screen modes along with the D65 standard white, the color of natural daylight at noon, which is marked as a white circle. To deliver accurate image colors for standard consumer photo and video content, the display must match both the standard color gamut and the standard color of white. 4 Galaxy S8 screen modes. The Galaxy S8 has 4 user-selectable screen modes. The AMOLED Cinema screen mode is an accurate match to the DCI-P3 standard gamut that is used for the new 4K TV content. The basic screen mode is an accurate match to the sRGB/Rec 709 standard gamut that is used to produce most current consumer content. The AMOLED Photo screen mode is an accurate match to the Adobe RGB standard gamut that is used with high-end digital cameras and advanced imaging applications. The adaptive display screen mode has the widest color gamut and is intentionally vivid. See these color accuracy figures for detailed measurements of each of the screen modes. Note that some of the screen modes are similar and their gamuts and white points overlap in the figure. The white circle marking the D65 white point is covered by the very accurate white points for the AMOLED Cinema, Basic, and AMOLED Photo screen modes. The adaptive display screen mode has an intentionally bluish white point. Figure 1a. Screen mode color gamuts in the dark 0 lux. The change in color gamut with ambient light. Figure 1 above shows the color gamuts in 0 lux ambient light, which is perfectly dark. Figure 1b below shows the decrease in 2 color gamuts with increasing ambient light, up through 2000 lux, which corresponds to typical outdoor daylight in shade. At 500 lux, which corresponds to typical office lighting, the on-screen color gamut for the basic screen mode on the left has fallen to 86%. At 1000 lux, which corresponds to very bright indoor lighting or outdoor daylight with an overcast sky, the on-screen color gamut has fallen to 75%, and at 2000 lux the on-screen color gamut has fallen to 58%. The way to improve the display color accuracy and performance in ambient light is to start with a larger color gamut, like the adaptive display screen mode, which is shown on the right compared to the basic screen mode on the left. At 1000 lux the adaptive display screen mode provides a much better match to the sRGB/Rec 709 color gamut than the basic screen mode. So the adaptive display screen mode provides more accurate on-screen colors in moderate to high ambient lighting than the other calibrated screen modes, which are designed and calibrated for low ambient light. Figure 1b. Basic screen mode in 0 to 2000 lux ambient light. Figure 1b. Adaptive display screen mode in 0 to 2000 lux. Galaxy S8 absolute color accuracy plots reference colors for the standard gamuts. Figure 2 a reference colors. Figure 2b cinema mode with DCI-P3 gamut. Figure 2c basic mode with sRGB/Rec 709 gamut. Figure 2d photo mode with Adobe RGB gamut. 41 reference colors for the new wide DCI-P3 color gamut standard. Figure 2a below shows 41 reference colors for the new wide DCI-P3 color gamut as white, gray, and black circles. The 10 black circles on the outer triangle are the 100% fully saturated colors on the periphery. The 3 inner sets of gray triangles are the 25%, 50% and 75% saturated colors between the inner white point and the 100% saturated colors on the periphery. The white circle is the white point with 0% color saturation. We have accurately calculated the colors and reference colors for each of the 3 Galaxy S8 standard color gamuts: DCI-P3, sRGB/Rec 709, and Adobe RGB. The colors in Figure 2 have been calculated to show the true colors within the DCI-P3 color gamut. The colors shown in most published color gamuts are wildly incorrect. For an in-depth, note that in order to see the true DCI-P3 colors in Figure 2, your display must support the DCI-P3 color gamut. If not, then you will instead see the color saturation range that your display can produce, which in most cases will be lower than DCI-P3. Figure 2a. 41 reference colors for the DCI-P3 color gamut standard. Note that complementary colors lie directly across from one another through the white point. The 4 sets of triangles are the 25%, 50%, 75% and 100% saturated colors. Absolute color accuracy plots. The Galaxy S8 has user-selectable screen modes. AMOLED Cinema screen mode, Figure 2b below shows the measured on-screen colors for the DCI-P3 reference colors. Basic screen mode, Figure 2c below shows the measured on-screen colors for the sRGB/Rec 709 reference colors. AMOLED Photo screen mode, Figure 2d below shows the measured on-screen colors for the Adobe RGB reference colors. Reference colors and measured colors. The reference colors in Figures 2b 2d are all shown as black circles and the measured colors for each of the screen modes are shown as red circles. Color errors smaller than the appropriate JNCD are not visually noticeable. The 1 JNCD and 3 JNCD errors are discussed next and are shown in the figures below. Just noticeable color difference JNCD. The on-screen colors produced by any display can be measured using a spectroradiometer together with our proprietary DisplayMate test patterns. The accuracy of the colors can then be calculated using the 1976 CIE uniform chromaticity color space and compared to the eye's sensitivity to color. We present the color accuracy and errors here in terms of MPCD minimum perceptible color difference or JNCD just noticeable color difference, where 1 MPCD equals 1 JNCD equals UV equals 0.0040 on the CIE 1976 uniform chromaticity scale. Color differences less than 1 JNCD are visually indistinguishable, while values greater than 1 JNCD are visually noticeable when the two colors are touching on screen. When the colors are not touching and are further apart, the visual threshold for just noticing a color difference is higher. Here we will use 3 JNCD for the threshold of a visually noticeable display color difference. The 3 JNCD color difference is shown in the figures below. Any display color error less than 3 JNCD on a display is not visually noticeable and appears perfectly accurate to the eye. Figure 2b. AMOLED Cinema Screen Mode Absolute Color Accuracy plots. The AMOLED Cinema Screen Mode provides an accurate color match to the DCI. Figure 2c. Basic Screen Mode Absolute Color Accuracy plots. The Basic Screen Mode provides an accurate color match to the standard sRGB/Rec 709 color gamut. Figure 2d. AMOLED Photo Screen Mode Absolute Color Accuracy plots. The AMOLED Photo Screen Mode provides an accurate color match to the Adobe RGB color gamut. Samsung Galaxy S8 image contrast and intensity scales. The intensity scale, sometimes called the gray scale, not only controls the contrast within all displayed images but it also controls how the red, green and blue primary colors mix to produce all of the on-screen colors. The steeper the intensity scale, the greater the on-screen image contrast and the higher the saturation of all displayed color mixtures. Intensity scale accuracy. So if the intensity scale doesn't follow the standard that is used in all consumer content, then the colors and intensities will be inaccurate everywhere in all images. In order to deliver accurate color and image contrast, a display must closely match the standard intensity scale. Figure 3 below shows the measured intensity scales for the 4 screen modes alongside the industry standard gamma of 2.2, which is the straight black line. Logarithmic intensity scale. Both the eye and the intensity scale standard operate on a logarithmic scale, which is why the intensity scale must be plotted and evaluated on a log scale as we have done below. The linear scale plots that are published by many reviewers are bogus and completely meaningless because it is log ratios rather than linear differences that matter to the eye for seeing accurate image contrast. Note that the intensity scales for the different screen modes are very similar and overlap on the graph. They are all somewhat steeper than the standard intensity scale. Light spectra. Light spectra for the Samsung Galaxy S8. Figure 4 a screen mode spectra. Figure 4b blue light filter spectra. LCD displays have backlights consisting of white LEDs, which are made by using a blue LED together with a yellow phosphor to transform some of the light for the red and green primaries. The spectrum of an LCD display is just the spectrum of its white LED backlight filtered through the individual red, green and blue subpixel color filters within the LCD panel, resulting in broad rolling spectra for LCDs. All displays are emissive devices, so their spectra are just the sum of the individual red, green and blue OLED spectra, modified slightly by the touchscreen layer and anti-reflection absorption layer through which their light must pass. As expected, the Galaxy S8 OLED spectra are relatively narrow with deep notches between the primaries, which results in highly saturated colors that are adjusted with display color management to provide high color accuracy for each of the screen modes. The difference in the relative heights of the green and red primary peaks for the user selectable adaptive display and basic screen modes in figure 4 below is due to their different white point color temperatures, which requires different drive levels for each primary color. The adaptive display screen mode has a bluish white point, so it has reduced green and red drive levels. Spectra for the adaptive display and basic screen modes. The blue light filter is designed to change the color balance of the display in order to reduce the amount of blue light produced by the display, which some recent research indicate can affect how well users sleep afterwards. As the user adjustable blue light filter opacity setting is increased, the on-screen images take on an increasingly yellowish tint bouquet, because amount of blue light emitted by the display decreases, which is seen in figure 4b below. With the blue light filter at its maximums, reduced by 80%. In a separate article we provide an in-depth scientific analysis on the issues affecting watching displays at night and their associated light spectra. Spectra for the blue light filter with off, middle, and maximum opacity settings.